This is the monthly review for semester 1. The subject is chemistry for grade 7. We first looked at how we should behave in the laboratory. And remember that we always should wear goggles, we have to wear a lab coat, we have to tie long hair, we have to wear gloves when handling dangerous products. It is forbidden to wear short sleeves, drink and eat in the lab, and breathe vapor of volatile substance or any substance for that matter. So safe practices include leaving the passages free, work in a stable condition, cleaning the bench when we've finished, and we have to move without running. Order and cleanliness. So we have to maintain laboratory equipment. You have to clean after you finish, make sure everything is disposed of correctly, and this will enable us to avoid accidents and work in a safe environment. If something is spilled, what we should do is that we should immediately wash it off using a sink, okay, and call your teacher. If you accidentally break glassware and there's glass pieces on your hand, what you should do is you put your hand under running water and call your teacher again. Do not attempt to take the piece of glassware out of your hand. Chemicals in the eye, you flush your eye, so you clean your eye with water and also call for your teacher. So if a person faints in the lab, and this is a life lesson, if they faint anywhere, you should lay them down on the back and try to raise the legs. Chemicals in the mouth, you shouldn't have chemicals in your mouth, but if accidentally it did go into your mouth, you should rinse your mouth with water and note the chemical that you are using so we can notify the nurse immediately. So these are the hazard symbols that are normally found in chemicals. Every bottle of chemical has one of these hazard symbols or more. It's very important for us to recognize these hazard symbols so we know what kind of chemicals we are dealing with. So the first one here, it's an explosive. Okay, the sign of a flame is flammable. The one that has like a flame over a circle is an oxidizer or oxidizing. The one looks like a gas cylinder is compressed gas. That means there's gas under pressure in there. So the one that has a hand and some chemicals coming out of it, so that is corrosion or corrosive. The skull and crossbow is toxic or acute toxicity. The one that has like an exclamation mark is an irritant or harmful. The one that has like a human figure in it is health hazard. And the last one is environmental, so it's an environmental hazard, so or aquatic toxicity, so it causes harm to the environment. We then looked at laboratory materials, and it's very important to recognize laboratory materials. So as you can see, this is a beaker. This is a container that is used to heat and mix liquids. Remember, we use this a lot in the lab when we heated pure water and salty water. We put it into a beaker first. Test tubes, these are used to hold small quantity of a product. A test tube rack is used to hold test tubes. So a round bottom flask is something that we use in distillation. We're not going to go into distillation now. It's something that we require further on in your studies. A graduated cylinder is used to measure a precise volume of liquid. Now it says graduated. Normally a graduated cylinder, okay, as you can see here, has got many lines, okay? It's got many lines. This is different from volumetric, which has only one line. So these are also more laboratory equipments. We've got the funnel. This is used to channel liquid into containers with a small opening. So rather than pouring it in and the liquid can spill everywhere, we can put it into a funnel which lets the liquid to drop slowly into the container. Separatory funnel, so this is used to separate immiscible liquids. Immiscible liquids is liquids that do not mix. We'll go into this later, but what a separatory funnel does, it allows one liquid to go first, especially if they have different densities. That means they will separate. Okay, so the two liquids will separate, for example, in oil and water. So what a separatory funnel will do, it will let the water to go out first, and then in the container, in the separatory funnel, we will have just the oil left. So a Bunsen burner is used as a heat source. We've seen this many times in the lab. A spatula is used to mix, spread and lift material. Rather than using our hands, we use the spatula. We then looked at matter. Remember, we said matter is anything that we touch, see or feel. So remember that matter can be classified into three different states. These are solid, liquids and gases. And the first matter that we're going to look at is solid. Remember, particles of a solid are very close to each other, as you can see in the image. This is why they have a definite shape, okay? So their shape does not change. They also have a definite volume, and remember, the volume is the amount of space that a substance or an object occupies. Examples of solids include ice, snow, table, chair. Okay, all of these are examples of solids. We then looked at liquids. Now, as you can see, the liquids have particles that are far from each other. Now, they're not as far as gas, which we'll see in a minute, but they're not as close together as a solid. They have an indefinite shape. That means they take the shape of the container, and we saw this in our lessons in physics. And they have a definite volume. So if we have 20 mils of water, that does not change. Okay, so 20 ml of water will stay at 20 ml of water. So they occupy a specific volume. Now, examples of liquids include water, Coke or Pepsi, rain, orange juice. Okay, these are all examples of liquid. The third matter that we looked at is gas. Now, as you can see, the particles of gas, they are very far from each other, and they take the space of the whole container that they're in. They try to stay as further away as possible from each other. They have an indefinite shape, so their shape keeps on changing, and the volume keeps on changing. So if I was going to put a certain amount of gas in a small box, they will occupy all of that small box. If I put this certain amount of gas in a big box, they will occupy the whole of the big box. This is why we say that the volume of gas keeps on changing. So this examples of gas is oxygen, nitrogen, and carbon dioxide. These are all examples of gas. We then looked at pure substances, and we said that pure substances have a definite physical and chemical properties. What does that mean? For example, we looked at the density of pure water, and remember when we measured the density of pure water, it was 1, and when we added more water, it stayed at 1. So that shows us that it has the same physical properties. It is impossible to separate a pure substance into simpler components. Pure substances are made of just one type of element or molecules. So this can either be a pure element such as oxygen, hydrogen and nitrogen. These are all pure elements, or a compound. Now H2O, they react chemically, so therefore this is why we call it a pure substance. Anything that reacts chemically we call a pure substance, like H2O, NaCl, which is salt. These are all examples of compounds that are pure substances. So a mixture is formed when 2 or more pure substances do not interact chemically. So this doesn't include water and carbon dioxide. Okay, they can't react chemically. For example, salt and water don't react chemically, so therefore that's why we call them mixture. It has a variable set of physical constants. Remember, in the lab we went and found the density of salty water. It was somewhere around 1.2. And when we added more water, okay, this changed. Okay, so this was not the same as pure water. Also, the boiling point, we saw that the boiling point of pure water was 100 degrees, while the boiling point of salty water kept on changing. So mixtures can be either homogeneous or heterogeneous. So if we have like a mixture in the middle, okay, this can be homogeneous, which we will look into later, or heterogeneous. So they're classified into 2 levels: homogeneous and heterogeneous. Homogeneous and heterogeneous. So homogeneous is a mixture that is made up of one phase. For example, when we put, for example, salt with water, what happens is the salt completely dissolves into the water. So therefore we can only see the water. This is what we mean by one phase. We don't see layers, we don't see the salt by itself or the water by itself. We see them mixed together, they completely dissolve. The salt completely dissolves in the water. So we call this homogeneous. So we can't distinguish them with the naked eye, and the different chemical substances which constitute it. While with heterogeneous, the mixture it's made of different phases. For example, when we put water plus oil, the water and oil do not mix. We see the oil by itself and we see the water by itself, and therefore they are visible to the naked eye even after we stir them. So that's the difference between homogeneous and heterogeneous. So let's have a quick summary about what we talked about. We looked at something called matter. We said matter is something that we can see, touch or feel. Okay, and we said that there are 3 types of matters, that's solid, liquid and gas. And we said we can separate these solid, liquids and gas into pure substances, or mixtures. Now pure substances could be elements. For example, oxygen, nitrogen, magnesium, iron, hydrogen, or they can be compounds. Okay, for example, water, table salt, ammonia, sugar, these are all examples of compounds. With mixtures, this can either be homogeneous, so we said homogeneous mixtures are things that made up of one phase, for example, salty water, or they can be heterogeneous. For example, pizza, sand and water, um, oil and water. These are all examples of heterogeneous mixtures. We then looked about analyzing graphs, drawing graphs, and for us to draw a graph, we need a table. So if I've given you like the first table, as you can see here, this table. Okay, so this table, you can see that we've got time, we've got temperature. And what happens here, it's the most important thing that you have to look at is that it stabilizes at 70. So it stabilizes at 70, and we say here that it's reached equilibrium. Now, because it has stabilized or reached equilibrium, we know that this is a pure substance. We know that this is a pure substance. And the boiling point for this substance is 70, and this is because it stabilizes at 70. If this is a boiling point and we've got something that's liquid, that means anything that's before the boiling point is going to be liquid, and anything at the boiling point is going to be liquid and gas. Now, for the second graph, which is this graph, we also have time and temperature. Now here, the boiling point is not really known, and it's normally given to us. It's because it's a mixture. How do we know it's mixture? Because it keeps on changing. Okay, it has not reached equilibrium. So this graph is a mixture. So normally the boiling point is given to you, what state it in. So if it's liquid and solid and gas, is also given to you. So these key is very important, that the difference between the tables of pure substance and mixtures is to see if it has reached equilibrium or not. As you can see here, with a pure substance, it stabilizes at 70, so it reaches equilibrium at 70, therefore it's a pure substance, while here it keeps on changing, therefore it is a mixture. We then learn how to draw graphs. Now I've put the table for the pure substance, but you should know how to draw the graph for pure substance or mixture. You just do what you've done now, what I'm going to teach you to do now, but you just change the plotting of the graph. So the steps are exactly the same, but how we plot the graph, so the numbers will be just a bit different. So first we need a scale. So scale is normally given to you. So here I'm going to tell you that the scale is 1 centimeter equals 2 minutes. 1 centimeter equals 10 degrees. So Normally the x-axis is the one that we have at the top here. So we're going to start off with 0. Remember, the scale says 1 centimeter every 2 minutes, so we have to go up in twos, okay? Just like what we have. 2, 4, 6, 8, 10, 12, 14, 16, 18, and then an arrow. And then the temperature, remember I said every 10 degrees is 1 centimeter, so we have to go up in tens. 10, 20, 30, 40, 50, 60, 70, and then an arrow. Now remember that we always have to label our graph. So here we've got time, which is in minutes, and temperature, which is in degrees. So let's plot now. So at 0 it's 20, at 2 it is 40, at 4 it is 50, at 6 it's 55, at 8 it is 60, at 10 it is 65, at 11, at 12 I mean, it is 40, 70. At 12 it is 70. So just let me make this a bit clearer for you so you know it's 12. It's 70. At 14 it's also 70. At 16 it's 70, and at 18 it is 70. So once we've drawn the graphs, we join the points by freehand. Okay. We just need to give a title for this graph. Temperature. Shown as a function of time. So this is normally the boiling point for the boiling point of a pure substance. Okay, for the boiling point for the boiling of a pure substance. So this is our title here. So this is what I've drawn on Excel. It's exactly what we did in the previous slide, but a neater version. This is so you can see it clearly. So I might tell you after you've drawn the graph is to analyze the graph. So we always start with 1 point, the first point. So there it is. At time 0 the temperature is 20 degrees, and then you have to describe the general trend. So you say, as you can see, as time is increasing, the temperature increases until it reaches 12 minutes at 70 degrees. As you can see here, at 12 minutes and 70 degrees, it stops increasing. And then we say after 12 minutes it remains constant. So as you can see here, after 12 minutes it has remained constant. Okay, and this is how we analyze graphs. Good luck, and I wish you the best in your exams, and I hope you do well.